Good morning students, welcome to video lecturing class on control engineering. So in the last class we have discussed about the block diagram reduction and used many rules to get the transfer function by reducing the given block diagram into a single block, single input and single output system. So today we will discuss about signal flow graphs. So it is one more way to representing the systems, particularly when set of equations describing the system is available. So this representation, which is obtained from the equation, which shows how the signal flows in the system. Okay, so we can call it as signal flow graph, as it uses the equations of the system, which consists of various variables of the system. The variable of the system plays a base role in signal flow graph. So on that base we can define the signal flow graph as the graphical representation of variables of set of linear algebraic equations representing the system is called signal flow graph. It is like your block diagram only. In case of block diagram, the set of differential equation is to build the block diagram. So here similarly, instead of block we are going to use the signal to represent the system. So as here some of the important elements which are consisting in this signal flow graphs are, as the variable are important elements of set of equations for the system. So these are represented first in signal flow graph by small circles called nodes of the signal flow graph. So these terms you will understand when we will move further. So now looking to its properties of the signal flow graph. So this SFG is applicable only to the linear time invariant system. Your system is non-linear, that time you cannot use this signal flow graph because it is very difficult to construct the system for such kind of elements. Then second one is the signal in the system flows along the branches and along the arrowheads associated with branches. So here the direction of the signal depends upon the direction of the arrows and it will flow along the branches. And the signal gets multiplied by the branch gain or the branch transmittance when it travels along it. That is, you consider a SFG as x1 is in a node, x2 is so a node. So in between it is having a gain as 4. So here the signal from x1 gets multiplied by 4 when it travels along the branch joining x1 to x2. So when it come out of this one, the value of this one will be 4. Okay. Then fourth one is the value of variable represented by any node is an algebraic sum of all the signals entering at the node. Then fifth one, the number of branches leaving at node does not affect the value of variable represented by that node. That means here the value or the gain you are going to consider from which the node has been started, the arrow has been started or the signal has been started at particular node, whatever may be the value, but when it passing through or when it is flowing through a particular branch, that time it is going, you are going to consider the gain of only that particular path. Then for a given system, the SFG is not any. That means you can represent in n number of ways for the given system in which you can build the signal flow graph. Then some of the terminology is used in SFG. So this is an example. The first one is a source node, the node having only outgoing branch. For example here, so here these are the nodes x0, x1, x2, x3, x4, and these are the branches, connecting branches x1 to x2, and this 1 or t1 to t2, 3 are the gains along that path. And these are the directions for the signals. So here source node is a starting node. Sink node, the node having only incoming branch. So here this x5 is only having incoming branch. So here also it is incoming and here also it is incoming. So we can call this one as a sink node. Then a child node, a node having incoming and outgoing branches. If you consider this x1, x2, x3, x4, they are having incoming as well as outgoing. If you consider this x1 incoming and outgoing, two outgoings. If you consider this x2 incoming and outgoing, that means it is having a both type of signal, that is incoming and outgoing signals. So that kind of nodes we can call it as child node. Then forward path, a path from a input to the output node. So in a given SFG, there may be more than one forward path. For example, to know those forward paths, you have to start from the input and end at the output. So if I start from here, x0 to x1, x2, x3, x4 and x5 is one path. Then x0, x1, x3, x4, x5 is another path. Then x0, x1, x3, from here I will go to directly x5. Like that, you have to check, and while considering the path, don't consider the signals which are in feedback path. Okay. So for the forward path, or the direction should be in forward direction. Okay. So then the fifth one is feedback loop, a path which originates from a particular node and terminating at the same node, traveling through at least one node without tracing any node twice is called as feedback loop. So here if you consider this x2, x3, x4 and coming back to x2. So here if I start from here, x2 to x3, x3 to x4 and coming back to x2. So here while moving with this path, it is not tracing node twice, any node twice. Okay. So for example, if I take this one as the starting point, x2, then x3, x4 and back to x2. Similarly, if I take this point as starting point, x1 to x3, x3 to x5, but I cannot go in this direction because it is in, for the signal direction is in forward direction. So your starting and end point should be same, and while traveling it must cross at least one node and it should not cross any node twice. So that is known as feedback loop. And then the next one is self loop. Starting and end point are same and it is not tracing any node in while traveling through the path. So here if I take starting from x3, going here and coming back to x3, so it is no node in between that path. So you can call that kind of loop as self loop. Then non-touching loop. If there is no node common in between two or more loops, such loops are said to be non-touching loops. So here if I take this one as the starting point, from x1 to x2, then coming back to x1 is one loop. From x2 to x4 coming back to x2 is another loop. So here this is L1 and this is L2 and they are not sharing any node here. So in that case you can call them as non-touching loops. Similarly here also L1, L2, L3 are there, that is starting from x1, x2 coming back to x1. These three loops are not sharing any common node. So we can call them as non-touching loops. Then loop gain. The product of all gains of the branches forming a looping is called as loop gain. So for example, if you are passing through the three nodes, okay, so that means you will be having two or three branches. Whatever the gain along with those branches, you can take the product of those gains. You can consider that gain product as the gain of the loop. Then to solve the problem, we are going to use Monson's gain formula. So here this formula is given by the overall transfer function is summation of Tk into delta k divided by delta, where this k is the number of forward path and the Tk is gain of kth forward path and the delta is system determinant to be calculated as. For that delta we are having the formula delta equal to 1 minus summation of all individual feedback loop gain including self loop. Whatever the gain we have calculated for the feedback loops, you have to take summation of those individual gains, then plus summation of gain into gain, product of all possible combinations of two non-touching loops, minus summation of gain into gain, product of combination of three non-touching loops. So how to write the gains here, we will understand when we start the problems. Then delta k is the value of above delta, that is whatever the value we have got it from this formula, by eliminating all loop gains and associated products which are touching to the kth forward path. For example, here if I am having k as 1, that is going to be my first forward path. So I have to eliminate the terms which are associated with that first forward path. So that is going to be my delta 1. Now moving further, we'll start with the problem. Find Cs by Rs, C of S by R of S, that is output by input, by using Manson's gain formula. So here the first step is you need to identify the number of forward path. So if I start from here to here, G1, G2, G3, G4 and output is one forward path. Then if I start from here to this node, direction is in forward direction, G5, G4 and 1. So this is the second forward path. And then check for any other combination. If I start from here, I cannot go in this direction because the signal is in opposite direction, and I cannot go in this direction because again this signal is in opposite. So there are only two forward paths, that is T1 is 1 into G1, G2, G3, G4 and 1. T2 is 1 into G5 into 1. Now the transfer function is given by the formula summation of k equal to 1 Tk into delta k divided by delta, which is equal to T1 into delta 1 plus T2 into delta 2 divided by delta, because there are only two forward paths. If there are three, that time you have to add one more plus T3 into delta 3. After finding the forward paths, number of forward paths and their respective gains, then you need to identify the individual feedback loops. So here if I take starting point as this point, G2 and minus H1. So starting point is this, I am passing through this node and I am coming back to this node, and nowhere I am tracing node twice here. So this is a loop number 1, L1 is minus G2 into H1. Similarly, L2 is starting from here, G1, G2, G3, G4 and coming back to G1 by tracing this minus H2. So this is going to be my L2, and the L3 is here. If I start from here, G5 directly, G4 and minus H2, coming back to the same point, that is origin point. So that is going to be my L3. Then identifying this is the identification of the individual loop. Then identifying the two non-touching loops. So here, if you take, this is my L1 and this is my L2 and this is my L3. So here if I consider the combination of L1 and L3. L1 is this and L2 is this. That means here they are sharing these two nodes. So we cannot say that they are non-touching loops. If I take L1 and L3, L1 is here and L3 is from here to this node and coming back to the origin, and your L1 is here. That means if you consider this L1 and L3, nowhere they are touching nowhere they are sharing the common nodes. So we can take L1 and L3 as two non-touching loops. That is L1 and L3 are two non-touching loops. Now delta equal to, the formula is 1 minus summation of gain of all individual loops that is L1 plus L2 plus L3 plus summation of product of two non-touching loops. So L1 into L3, like this you have to write. So here in this formula, find gain into gain, product of all. For example, here if you are having one more loop, say L4, and L2 and L4 are the non-touching, that time L1 into L3 plus L2 into L4, like that you have to write. And there are no three non-touching loops, so the next term will vanish. So 1 minus, substitute these values, L1, L2, L3 already we have written. You will get the delta as 1 plus 1 into, sorry, here it is 1 minus G2 into H1 plus G1, G2, G3, G4, H2 plus G4, G5, H2 plus this term. Now, we need to find out delta 1 and delta 2. So, for T1, that is for first forward path, all loops are touching. That means, here, this is the first forward path and your all the three loops are sharing the node which is on the first forward path. So to eliminate all the terms or all the loops which are touching first forward path in this delta equation. So when all are touching, we left with delta 1 as 1, that is eliminating all loop gains and product from the delta. Similarly, delta 2, so if you consider second forward path, L1 is non-touching here in this diagram. L1 is here. Okay, so if I start from here, coming to this node and moving through this G5 and I am having output here. So this is my second forward path. So here this L1 is nowhere it is sharing a node of this forward path, but L2 and L3 are sharing. So you have to eliminate L2 and L3. So L1 you have to keep as it is. So that is 1 minus L1. So here in this formula I have written L1 and L3, but you cannot keep L1 alone because it is a product. So once it becomes 0, so obviously it will become 0. So 1 minus L1 is the delta 2, that is 1 plus G2 into H1. Substitute those values, you will get the transfer function for the given signal flow graph. So with this we'll end this session here itself. So here, to solve the problems on signal flow graph, first step is very important to identification of the forward paths, that is number of forward paths and their gains. Then identification of the feedback loops, that is number of loops and their respective gains. Then identification of the two non-touching loops and three non-touching loops, that is combination. Then you have to write that Monson gain formula. Then you have to write the equation for delta, and while determining the value of delta 1 or delta 2 or delta 3, you have to eliminate the associated loop gains in that delta. So to solve this one, you should understand the basic definition of what is loop, what is feedback loop, what is node, what is a branch, and what is gain. So go through this theory part and this problem. So in the next video, we'll try to solve some more problems. If you have any doubt, you can comment in the comment box. Thank you.